all the time. For example, changing of coal when it is burned to produce heat, changing of milk into curd, and rusting of iron when exposed to moisture. All these changes are a result of chemical reactions. These chemical changes can be represented through chemical equations. In this lesson, you will learn about writing and balancing chemical equations. At the end of this lesson, you will be able to define a chemical reaction, explain the symbolic representation of a chemical reaction, identify the components in a chemical reaction, explain how to write a chemical reaction, and balance a chemical reaction. Let us see what a chemical reaction is through an experiment. We begin with some zinc granules in a conical flask. These granules are blue-gray in color. Fit a 2-holed rubber cork on this flask. Then we fit a thermometer into one hole of the cork and a thistle funnel into the other hole. Next, pour 5 ml of dilute sulfuric acid into the conical flask through the thistle funnel. The color of the zinc granules changes from blue-gray to white. Some gas bubbles are also released from the solution. This is because zinc reacts with sulfuric acid to form zinc sulfate and hydrogen gas. Zinc sulfate is white in color. The thermometer shows an increase in the temperature of the solution. Therefore, as you saw in this experiment, the color of zinc changed during the reaction. That is, there was a change in physical properties. The reaction also resulted in the evolution of a gas. That is, the form of the reactant changed. Zinc reacted with sulfuric acid to form zinc sulfate, a salt. Thus, the composition of the reactants changed. Hence, we can say that a chemical reaction involves a change in the physical and chemical properties, the composition and the physical state of a substance, whether an element or a compound. A chemical reaction is typically expressed in terms of a chemical equation. A chemical equation indicates the components in a reaction, the physical state of each reactant, and the products of a reaction. Thus, a chemical equation is a symbolic representation of the reactants and the products, using their chemical formulae. For example, zinc reacts with dilute sulfuric acid to form zinc sulfate and hydrogen gas. This is represented in the form of an equation, as shown here. Solid zinc reacts with dilute sulfuric acid to form an aqueous solution of zinc sulfate and hydrogen gas. A chemical equation is made up of the following components. The reacting substances, known as reactants, are on the left-hand side. For example, in the equation you just saw, zinc and dilute sulfuric acid are the reactants. Therefore, they are on the left in the equation. The resulting substances, known as products, are on the right-hand side. For example, in the equation, zinc sulfate and hydrogen gas are the products. Hence, they are on the right. An arrow separates the reactants and the products, and also indicates the direction of the reaction. Thus, in the reaction you saw, the arrow indicates that zinc and sulfuric acid react to form zinc sulfate and hydrogen. Let's take another example that involves two substances. In the burning of coal, carbon reacts with oxygen to form carbon dioxide. In this reaction, carbon and oxygen are the reactants and carbon dioxide is the product. The chemical equation for this reaction is as shown. Solid carbon reacts with oxygen gas to form carbon dioxide gas. In chemical equations, you denote a solid with S, a liquid with L, a gas with G, an aqueous solution as AQ. A gas produced with an arrow pointing upward. Precipitate formed with an arrow pointing downward. The reactants and products are separated with an arrow which points in the direction of the reaction. Let us consider the reaction of iron with steam. Solid iron reacts with steam to form solid iron oxide and hydrogen gas. This reaction is represented as shown. A symbolic representation of a chemical reaction is the first step in writing a chemical equation. The next step is to ensure that the equation is balanced, considering the law of conservation of mass. The law of conservation of mass states that the total mass of the reactants and the products should be equal. This means the number of atoms of an element on the reactant side should be the same as the number of its atoms on the product side. All chemical equations must adhere to the law of conservation of mass. Therefore, all chemical equations need to be balanced. The process of balancing a chemical equation involves 4 steps. Determining the reactants and products in a reaction. Counting the number of atoms of each on both sides. Selecting the elements that occur for the least number of times in the equation. Balancing typically starts with such elements where the number of atoms is not equal on both sides. Changing the coefficient of the molecules of reactants or products as required. You should continue balancing the atoms in this manner till you have covered all the elements in the equation. In the end, do a final check to confirm that the number of atoms on the reactant side and the product side have been properly balanced. Here is a word of caution. When you balance equations, use coefficients only on the left of the symbols of elements and compounds. Never change the formula of a compound or an element to balance an equation. To understand how an equation is balanced, let's refer back to the reaction of hydrogen with oxygen to form a molecule of water. We need to balance the equation for this reaction according to the law of conservation of mass. The first step is to determine the reactants and the products in the equation. Here, hydrogen and oxygen atoms are the reactants. Therefore, they are written on the left-hand side. The water molecule is the product, and hence it is written on the right-hand side of the equation. In the second step, you need to count the number of atoms of each type. You'll notice that hydrogen has 2 atoms on the reactant side and 2 atoms on the product side. But oxygen has 2 atoms on the reactant side and only 1 atom on the product side. So there is 1 oxygen atom less on the product side. According to the law of conservation of mass, the number of atoms on the reactants and product side should be the same. In step 3, you need to select the element that occurs in the minimum number of places in the equation. You can see that there are 2 hydrogen atoms on each side, while there are 2 oxygen atoms on the left-hand side and only 1 on the right-hand side of the equation. Hence, oxygen has to be balanced first. Finally, in step 4, you change the coefficient of the molecules of the reactants or the products. To do this, you need to first select the oxygen atom and balance it by placing the coefficient 2 before the product H2O. Now there are 2 oxygen atoms on the reactant side and 2 on the product side. However, placing the coefficient 2 before H2O gives 2 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. Thus, there is an imbalance in the number of hydrogen atoms. To balance the hydrogen atoms, place the coefficient 2 on the left hand of hydrogen on the reactant side. Now, let's take a look at the final equation. The atoms of each element on the left and on the right hand side of the equation are now balanced as per the law of conservation of mass. According to the final balanced equation, 2 molecules of hydrogen react with 1 molecule of oxygen to form 2 molecules of water. Let's practice further on balancing equations with another example. This equation deals with the combustion of ethyl alcohol. Again, the first step is to identify the reactants and the products. Here, ethyl alcohol and oxygen are the reactants, and they are written on the left-hand side of the equation. The products on the right-hand side are carbon dioxide and water. Step 2 is to check the number of atoms of each type on either side. Here we have 2 carbon atoms on the left-hand side, but only 1 on the right-hand side. 6 hydrogen atoms on the left-hand side, but only 2 on the right-hand side. 3 oxygen atoms on the left-hand side, as well as on the right-hand side. Let us begin balancing the equation by selecting carbon. There are 2 atoms of carbon on the reactant side, but only 1 atom on the product side. So to balance this, add the coefficient 2 before carbon dioxide on the right-hand side. Now, let's consider the next element, hydrogen. There are 6 atoms of hydrogen on the reactant side and 2 atoms on the product side. To balance this, you need to place the coefficient 3 before H2O on the product side. Now, as you can see, hydrogen has been balanced. The next element in the equation is oxygen. There are 7 oxygen atoms on the product side, but only 3 atoms on the reactant side. To balance the equation, place the coefficient 3 before oxygen on the left-hand side. In the end, do a final check to confirm that the number of atoms on the reactants and the product side is properly balanced. Here is what you get as the final equation. Ethyl alcohol reacts with 3 molecules of oxygen to give 2 molecules of carbon dioxide and 3 molecules of water.